And the other ones are, I don't know how good the recording is going to come out. We'll give it a go. I think the lighting is going to do that. So another way to think of it, that's 3. So 0, 1, 2, 3. So that one goes here. Okay, what about x prime, y prime, z prime? 0, 0, 0. That goes here. And then this last one is 1, 0, 1. So again, you can just figure out where the variables 1, 0, 1 would go here, or you know it's a 5. 0, 1, 2, 3, 4, 5. So however you want to do that. Okay, so now we need to think about how we can solve this. So we need now to find, I feel like I did some code. Okay, so I need to try, so the idea is if I look at these two down here, this is x, y prime, z, and x, y, z. The y and the y prime will combine, right? If I were to factor out the x and z, let's just look at this one here. So this is going to be x, y prime, z, or x, y, z. If I factor out the x, z, I get y prime over y, so that's just x, z. So, and that only works because they're adjacent to each other. There's only a difference between one's got a 0 and one's got a 1 in the same variable. So if you don't renumber them oddly, they're not going to be different by only 1. So that's why we have to do the weird one. So this one down here is just xz. What about this one?
YZ?
Yeah, so here, we don't need to write it out this way. We can look at this and say the x values don't matter. 0 and 1 are both there. What's the only thing that's constant? YZ. So we're going to, so the red will just be YZ. And then lastly, what can I do with this one? Can this one combine with anything? No, that's why I circled it by itself. So that's going to be x prime, y prime, z prime. So then your whole final simplified solution is xz plus yz plus x prime, y prime, z prime. It's just simpler than doing all the algebra, and you make fewer mistakes. So once you get the ones in the right place, you're just circling things. It's fine to cover it more than once. You have to cover every one. You don't have a choice on that. You got to cover all the ones. Is that all right? All right, so let's look at the next one that we listed over there. So 3. And then at some point I'm going to have you pull out a bunch of the pages I gave you last time. F of ABC is equal to AB prime or AC or AB or B. You might look at that and be able to see that that simplifies right off the bat. What do you see immediately that you can do? The A, B, or B. AB is part of B, so that would just simplify B. And then we've also got AB prime or AB. Factor out the A, get B or B. So there's a lot of simplifying that can be done here just looking at it. Let's go ahead and get it in a K-map instead.
We assume if the variable's not there, that it's 0?
No, that's why it's important you say which ones, because there's no D, which means it's not a 4-variable thing.
Well, I meant like, because it's A,
So, oh yes,
B prime, is
yeah,
that C is 0
yes.
or a 1, or is it both?
It's both.
Both.
Right, so when I see AB prime, that means C doesn't matter, so I have to put a 1 both where C is 0 and where C is 1.
Okay.
Right. So 0, 0, 0, 1, 1, 1, 1, 0. Okay, AB prime. That's where A is 1 and B is 0. And C doesn't matter. So I get 1 here and 1 here. Okay. And then if I look at, oh, that was weird. I can make the red lines appear and disappear. And then they're going again. Okay, I don't know what that's about. Let's see if that helps. A little. Okay, so AC, that's where A is 1, and C is 1, and B doesn't matter. So A is 1, C is 1, B doesn't matter. So I'm going to go ahead and try and draw those in. Now I'm going to put an extra 1 there. It's not a 1, 1, it's not an 11. It just gets tagged more than once. That's okay. So that was this one. What about AB? AB is where A is 1, and B is 1, and C doesn't matter. I'm just putting a 1 everywhere. In the end, anywhere there's multiple 1s, that's still just only 1. It doesn't matter. B is where B is all 1, and A and C don't matter. So where is B equal to 1? Here and here. C doesn't matter, and A doesn't matter. So I get 1s here as well. Sort of didn't draw my colors very well. Oh, and there was a 1 also here and here. So there are a bunch of cells that got tagged more than once. That's okay. That's where the simplification came in. If we were to simplify this algebraically, that we would be eliminating those. So looking at this, what do I see? I'm looking for the biggest group I can find. I can't circle all 8, and I can't circle 6, but I can get this whole group of 4, right? Like that's all those 1s. So I can do this. What is constant in that? Whatever is constant is what, so what's the only thing that's constant? A is equal to 1. B and C don't matter. So that's just A. And then what about this one? I see this one. What's constant in that one? I think B is 1. C doesn't matter, and A doesn't matter. So that's just B. So F, in this case, simplifies to A or B. Do you need to put all the extra 1s in? No. Once you've got a 1 there, you don't need to put another 1 in. I just wanted to show you that kind of where they all come from. So no, you don't need to you don't need to have extra 1s. That's just kind of like saying you got tagged more than once. So the other thing you could do is you could have converted this to min terms, right? I could have multiplied by a C or C prime and then, spread them, distribute it out and that's just a lot of work. You don't need to do that. So the whole thing about K-maps is, if I want AB prime, that's where A is 1, B is 0, C doesn't matter. So I'm going to have 2 1s that come out of that. And likewise, when I go backwards and I circle something and I say the only thing that's constant here is A is 1, then that's how I describe that, because B and C don't matter. So it simplifies to just A. Okay, so that's kind of how we work with K-maps, is that the only thing that gets a variable is the thing that doesn't change. Okay, so let's look at, go ahead and pull out, from last time, go ahead and pull out these. We need to talk about 4 variable K-maps. We can't have 4 variables. 4 variables gets us how many levels? 16? Do we want to draw a 16-row truth table? We would prefer not to. K-maps will be good for us. Notice that the ordering is still the same going across the top. 0, 0, 0, 1, 1, 1, 1, 0. Notice it is also that same weird ordering going down the side now. 0, 0, 0, 1, 1, 1, 1, 0. Okay, so it goes in both directions. It's kind of hard to remember that sometimes. Same thing. Adjacent cells connect, going off the right and left sides connect, going off the top and bottom connect. Let's define a few things first. A literal, we know what that is, right? Every time that any letter is used, even if you have to repeat them, and that's okay, because a literal kind of stands for a gate input. So if you use A more than once, that means it's going to be put into a gate more than once. So you need to count, if there are 2 A's, that counts 2. Cover just means include, draw a circle around, however you want to think about that. Implicant is any circle, any product term that includes some 1s. A prime implicant is the biggest circle you can draw at that location. So if you can draw 2 2s, you can also draw a 4. The 4 is bigger than the 2 2s. So the prime implicant is sort of the biggest grouping, which means the fewest variables that you can draw in that location. An essential prime implicant is one that it covers a 1 that is not covered any other way. So the essential ones are the ones you have to have because nothing else will get some of the ones that are in that group. Implicants can cover each other, they can overlap, that's not the problem. So the problem is you need to get everything that you have to get, and then on top of that, then it's kind of a matter of what's the best way to do that. So there's a little bit of science and a little bit of art. Okay, so, and you will need to know vocabulary, so feel free to get that out of it. Okay, so let's look at these. So we don't need to redraw. So here we're just going to be drawing circles. So what do we see that would, how do we want to, what do we see that would be useful here? Bottom row. Does everyone see that? Bottom row? That one should be pretty obvious. So bottom row.
Is that isolated one considered an essential problem?
Yes. So is there anything I can do with this one? Does it combine with anything? No. So that means I have to circle it by itself. It is essential, because that's the only way to get that one. There's nothing I can do about that. What about these two?
Don't you go around?
Yeah, I could circle these two, but a bigger would be 4, and that's going to be smaller. Because remember, the bigger the group, that means the more things don't matter, the more variables that don't matter, which means the fewer variables that you have left in that term. So we're going to do this. And that's kind of how we draw it. Okay, so what is the expression for this term across the bottom, black circle? A is 1, B is 0, and C and D don't matter. So this is just A, B prime. That describes this down here. C and D don't matter, because there's a 1 in all of them. So I would say that this is equal to A, B prime. That's the black circle. Red circle. What stays constant for the red circle? Looks like D is 1, C changes, so that's not going to be in there. So D is 1, what else is constant? B is 0. So B is 0, A varies, so that's not in there. B is 0, and D is 1. So this would be B is 0, and D is 1. So to get the expression for what you've circled, you're looking for what does not change. And then lastly, what about this one? So it's A prime, B, C, D prime. There's nothing you can do about that. So plus A prime, B, C, D prime. So again, the expression you're writing for the circle is for the variables that do not change. The ones that do change are what you would, those are the things that, you know, like if all 4 combinations of A and C you could multiply by, and all those 4 combinations are going to add or to 1. That's why we don't need to include that. All right, so what about this one? Take a crack at that one. Do some circles. You may find some overlaps, so you're going to have to see what you can do.
You said if they're redundant, don't draw the circle.
You always want the biggest circle. If it overlaps another big circle, that's
What do you
okay.
mean if there's 2 circles and then 2 circles in between them?
So like these 2 should be one big 4, not 2 2s.
Yeah, but
Yes.
I'm talking about, so on the bottom there.
These 2.
You have those 2, and then
Oh, and then that one.
go,
And then that one.
and then that one, and then that one,
Yeah,
and
so
then that
we're
one.
let's look for the biggest circles first.
Can't we just do
So
two big circles?
clearly we have this one.
Well, you can get the bottom too.
Yeah, exactly.
Because you can, there's like,
But do we agree that to get these 2 in the biggest circle I can, this circle of 4 gets these 2?
you can go,
Can't
You
you
go
go
like
you
one
can't
around.
skip the bottom?
Exactly.
Oh, sorry.
Yeah, not done yet. Yes, we need these, but do you agree we need both?
Can't you do all?
you can't do
all
6.
Can you do
You
all
can't
six?
do,
Why?
Yeah.
because it has, really? It has to be powers of 2, because you have to have all the combinations that OR together to 1. So I can't draw the 6 because
Oh.
those guys aren't in there, right? So it's got to be powers of 2. You can't draw 6. It's on the slide. So this one is required. It's the biggest group I can get that gets these. The red one is the biggest group I get that gets these. So now what else do we need to do? I could circle these. So this gets these. What about this one? You could go this way or this way. Anybody see it?
There's a lot of ways you can go.
There are 4 corners. That works too. The corners are all connected. So that's kind of,
Oh, you need
right, because these are connected, going off to the left and the right are connected, going off the top and the bottom are connected. So this one's kind of cool, so I need another color, but I don't have it, right? So we're gonna do,
You want green?
I'm trying to.
I got green.
So this is technically a sphere.
It's a different issue. So we have
Oh.
this. Okay, so let's start with the first blue one, the first easy one. So what's constant? A is 0. Yes, Mike.
So you can't circle that one on the top of the right itself?
You could, absolutely you could, but that's a big term. We're always
Oh.
looking for the smallest terms we can get.
Gotcha.
So we want the biggest circle we can draw that includes something. So this big one is easy. A is 0 and I think C is 0, that's what's constant. Because B changes and D changes. So this first one is going to be A prime, C prime. That's that first one. What's the red one? What is the same here? Looks like A changes, B is 0. That's what's constant. B is 0. And then what's constant between these? C is 0. So I'm going to have B is 0 and C is 0. What about this guy? Is there any other way to get this 1? I think this little circle of 2 is the only way to get this 1. So these are both essential, and I think this one is essential also. It's the only way I can get that one, because it doesn't connect anywhere else. Yeah,
Could you have isolated that one and then delete the other two?
you could. Yes, you could do that too. But it's better to have overlapping big circles. Bigger is better, hands down, full stop. That is the goal of KMAP. The bigger the circle, the better. Overlapping doesn't matter. So this is the biggest circle I can get that includes that. So what stays the same then? Looks like A is 1, C is 1, and D is 0. So I'm going to get A, C, D prime. Now I got to figure out how to get this last guy. I could do a circle of 1. I could do a circle of 2. Or a circle of 2. Or 4 corners. That's very cool. So let's think about what stays the same between the 4 corners. I get B is 0.
And D is 0.
And I get D is 0. And A and C don't matter. I have all the combinations of A and C. I have A0, C1. I have A0, C0. I have A1, C0, and A1, C1. So all the combinations of A and C are represented. That means they OR together to be 1. So I don't need to include them. So what stays the same? B is 0 and D is 0. So that's B is 0, D is 0. That's the 4 corners.
Do the diagonal corners
No,
link?
they do not. So we link right to left and top to bottom, but not diagonal. Because too many things change. Yeah, that's a good question. Yeah, so diagonal does not connect. So I could have just done these 2, and then I would have had B prime, C, D prime. I would have had B prime, C, D prime. So that is part of this one, right? So so that one would be a bigger gate because it would have 3 inputs. This one only has 2. So again, you're just looking, the bigger is better because bigger grouping means more variables don't count, which means the ones that are left are fewer, which means the gate is smaller. Does that make sense? So we're always going for bigger circles, always. That's our number 1 goal. Overlapping doesn't matter. The only thing we don't want to do is do things more than once. So once I've done the 4 corners, I don't also want to do just these 2, right? Because that's the same thing. I don't need to do that.
So ignore redundancies.
Okay?
So ignore redundancies if we can.
Yeah, you can overlap. Overlapping is the number 1 goal is big. Secondarily, you don't want to do something that you don't need to do. So if I've already got the 1 covered somewhere else, I don't need to create a new thing just to do it again. So I need to get every one at least once, biggest circles possible. Overlapping after that doesn't matter. All right, so let's look. I don't think we'll do all of these. Let's look at, let's just draw a quick K-map just so you remember how to do these. So again, I tend to draw a big box, and then I draw my lines through the middle, and then I draw my lines through the middle of that. And I try really hard not to drag my hand over the corner and smudge the ink. AB, CD. So I do most significant to least significant. Some people do it the other way, just so you know. And now I got a number in that same weird way. So 0, 0, 0, 1, 1, 1, 1, 0. Going the same way down the side. 0, 0, 0, 1, 1, 1, 1, 0.
How many variables can you do this for?
We're only going to do 3s and 4s. You could do more than that, but I'll show you 5 in just a second, which we won't do. Okay, so now I need to put them in. So I'm going to count 0, 1, skip 2, 3. So 0, 1, skip 2, 3. 4, 5, skip 6, 7. So I'm going to have 4, 5, skip 6, 7. Skip. You always got to skip the third row or column. So now when I go, so I'm going to get 7 to here, and then 8's down here. This is 8. Not this row. So skip, come back. So I want 8, 9, 10, 11. And then I want 12, so 12 is up here. Apparently just right. 0, 4. And then I need 12, 13, 14, 15. Well, this simplifies to be really, really fast. This one is very fast. So let's look at this. I see this group of 4, and I see this group of 4. Do I also need this group of 4 in the middle? I have covered everything already. So I could do this one here, I dotted in red. But that one is unnecessary. Okay? So the black one is going to be F is equal to the black one. What stays constant here? A is 0, B doesn't matter, C is 0, D doesn't matter. So A prime, C prime. The column, what stays, columns are usually easy, or rows. CD, that's the only thing, right? All the different combinations of A and B, so CD. And then red dotted is unnecessary. That one's unneeded because we've already covered everything. We don't need to do it again. We've already got everything. So the first two are essential prime implicants. Essential because they're required to get the ones. Prime, so essential because they're required. Prime because they're as big as they can be. Implicants because they cover things. Does that make sense? Okay, I'm not going to do this last one. I'll write it out, but it's going to go kind of the same way. Again, when you're starting to put these in, I would think of this as x equals 0, z equals 0, and find all the squares for which that's true. And this is y equals 0, z equals 1, find all the squares for which that's true. That's where the 1's go. You don't have to write multiple ones if you don't want. Okay, so let's look at here yet. All right, hang on just a sec. So a couple things I want to say first. The bigger the group, the smaller the variable term, right? Because the bigger the group, the more combinations are included, the more variables don't matter, so what's left gets smaller and smaller. So in a group of 8, there's only one thing that stays constant. The 8 combinations are combinations of 3 variables, there's only one left. There is a 5 variable K-map, and essentially what you do is you take a 4 variable, and in your mind stack it on top of a 5 variable, and they combine layer to layer. So the corner here is connected to the corner down here. So we're not going to do that. It is. It's 3-dimensional. That's the only way that works, and so that's hard to draw. So we're just so you know that that's there. Most of the time we use K-maps for 3s and 4s because we can draw those 3 and 4 variables. So that won't show it here. So these side by side do not. That's not how they match up. They match up top bottom. So these two and these two would match up because top of each other. So again, we won't use 5s. Okay, we can use K-maps to get SOP or POS. SOP is sum of product, that's what we've been doing. POS is product of sum. Can't tell which one's going to be smaller until you try it. So let's look at these ones. First let me just show you. So the idea is you're going to put in all the ones. All right, so you're going to put in all the ones, and then in order to get POS, you're first going to just get all the zeros, and then you're going to do De Morgan's on it. So you're going to count everywhere there's a 0, and then do De Morgan's. That's kind of our process. So what we have been doing up to now is sum of product. You just figure out what it is for the ones. So for product of sum, the first thing you do is write this for F prime, and then when you do a De Morgan's on it, you end up with a product of sums instead of a sum of products. All right, so let's do an example.
Would that be for maximums?
Yes, so these would be max terms, exactly that. Okay, and I know the book says we don't really cover max terms. It's something to entertain. A lot of people don't. You don't have to do max terms, but it's just kind of an interesting combination. All right, so let's look at this one. Right here. This one. So we're going to do it 2 ways. I have two. This is one problem. We're going to do 2 different ways. I just wanted to not clutter the same diagram. So here, let's go ahead and get in. So hang on just a second. I want to check one thing, make sure I wrote it right. Yeah, so this should be a sum. So this symbol right here should actually be a sum. Okay, so now we're going to put a 1 in. 0, 1, skip 2. So go ahead and put in your ones. 0, 1, skip 2, not 3. 4, 5, 6, 7, 8, 9, skip 10, 11, 12, 13, skip 14, and that's what we're doing. Everywhere else is a 0 then, right? So you put in the ones and then everywhere else is a 0. You can put the zeros in, but you don't have to. So if we're going to group these, I see this one. I see this one. We have some options. Do you agree we could do either this one or this one? Does it matter? No, actually it does not. To get these, I know the only way I can get that is this. The last one doesn't matter. I could either do these 2, or all 4 again. This is the exact same problem. Is it the exact same problem?
Yeah.
All right, so never mind. So we've done this one already. Yes, thank you. So let's just write down the answer. So yes, and then we know the 4 corners. All right, so let's just write down what our answer was before. Very good, we don't need to do that again. All right, so we have F is equal to A prime C prime, or B prime C prime, or B prime C D prime, or A C D prime. So how many inputs, how many gates? 2, 4, and 6 more is 10. And then 1, 2, 3, 4, I get 14 inputs. Does that sound right? 2 inputs here, and 2 more, and 3 more, and 3 more, that's 10. And then we have that one big gate at the end, so I get 14 inputs. And assuming that I could have as big a gate as I wanted, I have 1, 2, 3, 4, and then one big OR gate at the end, 5 gates. And I'm going to put a 5 plus because we may not have, if we don't have multi-input gates, just have the 2 input gates that we do. All right, so now we're going to come over here. We're going to fill in all the zeros. Oh, right, I'm sorry, because I was copying.